Good day to our thesis advisor, Engineer Lemuel Epe, to the panelists, and to the chairperson, Engineer Juanito Orenes Jr. I am Nelwayne P. Galamiton and I would like to greet you all a pleasant day. We will be presenting to you our research study entitled Design and Fabrication of a Machine that Produces Pipe Clamps Using Scrap Flat Bar and Galvanized Iron Sheet, together with my co-researchers, Mr. R.G. Sigabillada, Mr. Japit A. Chavez, Mr. Arf McCain Grasso. Introduction. In the Philippines today, the annual solid waste generation rate is about 10 million tons, which translates to approximately 0.3 to 0.7 kg daily of garbage for each Filipino, which the World Bank estimates to grow by 40% by the end of the decade. Much of this is concentrated in the urban areas, where up to 44% of this waste is recyclable. Recycling thus offers some of the most pragmatic solutions to reduce the volume of generated waste. In local community, there are many waste metals, specifically from the fabrication and junk shops, that are being neglected and disposed improperly. Metals of such materials have been very expensive nowadays. To use these materials, the researchers are planning to fabricate a machine that can produce pipe clamps with a specific size. Pipe clamp are often referred to as pipe clips or sometimes saddle clamps, are found in all manner of household, industrial, and outdoor settings.
Statement of the problem. Though there are existing pipe clamps in the market, the commercial pipe clamps are costly in nature, and in Bohol, there is not yet pipe clamps factory, so we need to import pipe clamps in other areas. Also, utilizing scrap metals is a foreign idea to most of the community in the Philippines. With the help of this fabricated machine, this will open skill building among the youth and could become an income-generating project to communities, providing opportunities and jobs, especially in this time of the pandemic. Also, the high volume of export of scrap to other countries is an avenue that we can utilize to help our economy flourish by means of recycling.
Objectives of the study. Number 1. To determine the specification of metal that the molder can be formed. Number 2. To design and fabricate a machine that produces pipe clamps using scrap, flat bar, and GI sheets. Number 3. To be able to produce a pipe clamp for pipe with 1-inch diameter. And number 4. To test and evaluate the performance of the machine. Governing equations to be used in designing the machine. Power transmission, chain design, Pascal's principle, frame design, and gear ratio. Testing the performance of the machine in terms of production rate per hour. Table 4.2 shows the production testing using the GI sheet, and Table 4.3 shows the production testing using the flat bar with thickness of 1.5 mm. For the production rate per hour, the researchers find out that the average production rate per hour using GI sheet with thickness 1 mm is 129 pipe clamps per hour, and the average production rate per hour using flat bar with thickness 1.5 mm is 115 pipe clamps per hour. See Appendix E.
Testing of machine in terms of power consumption. Table 4.4 shows the data gathered of power consumptions using GI sheets with 5 trials using galvanized iron sheets. Also, Table 4.5 shows the data gathered for power consumptions using flat bar with thickness of 1.5. Table 4.4 and 4.5 shows the electric consumption using the flat bar GI sheet. The researchers made 5 trials each of the materials in order to find the difference of every operation. Based on the data, the researchers gathered the average power consumption of the machine in using GI sheet of 0.001388 kWh and using flat bar with thickness of 1.5 mm is 0.001678 kWh. See Appendix F.
Findings. The overall finding of the research would result to the approximate functionality of the machine that can produce a production rate of 129 pipe clamps per hour using scrap GI sheet and 115 pipe clamps per hour using scrap flat bar, which means it can be effective in making pipe clamps and production purposes. Conclusion: the researchers had made the machine successfully, reaching its main objective to utilize scrap metals, specifically flat bar and GI sheet, to produce pipe clamps. The pipe clamp maker machine was fabricated from locally sourced materials and recyclable metals. The machine can approximately make 129 pipe clamps per hour using scrap GI sheet and 115 pipe clamps per hour using scrap flat bar, and would result in a product that is exactly the same output as found in the market. Recommendations: the researchers would recommend in upgrading the machines. These recommendations are: 1. Removable upper and lower dies that is suited for other pipe sizes. 2. Automatic control of the release of the lock of hydraulic jack. 3. Automatic removal of finished product in the molder using the pneumatic cylinder. 4. The material to be pressed must depend on the design on the molder so that it will be formed accurately. 5. Puncher for the design of the two hole. Thank you for listening on our virtual presentation entitled Design and Fabrication of a Machine that Produces Pipe Clamps using Scrap Flat Bar and Galvanized Iron Sheet. And the room is now open for questions, suggestions, and recommendations. That would be all. Thank you. Good day, our beloved panelists. This is our machine. Here, focus. And this is our parts, basic parts. This is the sprocket to pump the hydraulic jack. And this is our molder. And our switch here. This one. And now we start how to operate the machine. This is our sample raw materials. Insert here. And we start it on. Here. After this, we release the jack pressure. Then we took this one, and this is our finished product.